Hey everybody, so this is an introductory video of hyperbolas, a type of conic section. And so to begin with, we have two different types of hyperbolas, a horizontal hyperbola and a vertical hyperbola. And what makes a hyperbola either horizontal or vertical is based on the vertices. If the vertex or the vertices of the hyperbola are anchored on the x-axis like so, right here, you have these vertices. If it's right on the x-axis, it's going to be a horizontal hyperbola. And if we have a hyperbola with vertices on the y-axis, like so, it's going to be a vertical hyperbola, just like that. Okay, so let's analyze the horizontal hyperbola. So to begin with, as you see the equation, in general, for hyperbolas, the x squared and y squared can switch spots, but the a squared and b squared, they stay there. As opposed to ellipsis, in my other video, I showed you that the a and b can switch, but the x and y stay input. But now we're talking about hyperbolas, so x squared and y squared could switch depending on the hyperbola. So in this video, horizontal hyperbolas, you begin with looking at how the x squared is on the first term. So if x squared is on the first term, you're going to know it's going to be a horizontal hyperbola. Now if looking at vertical hyperbolas, y squared begins here, that means it's going to be a vertical hyperbola. But now back to horizontal hyperbolas. As you see, x squared is in the beginning here. You know, it's a horizontal hyperbola with vertices on the x-axis like so. And an important part of hyperbolas are the oblique asymptotes. The oblique asymptote for a horizontal hyperbola has b over a. The vertical hyperbola has a over b. But now here, the oblique asymptote is b over a, so you get b from here, you square root that, you get b, because right here in the denominator is going to be b squared. So you square root that, you get b, you put it over a, square root a here, put it over a, and you get a sort of a y is equal to mx, a slope, a linear equation, y is equal to mx, and a plus or minus, because you have a plus and you have a minus. And yeah, basically those are the asymptotes of the hyperbola. And for vertices of a horizontal hyperbola, it's going to be plus or minus a comma 0. Moving on to vertical hyperbolas, right here you see the vertices are 0 comma plus or minus a. See difference here? For a horizontal, it's going to be plus or minus a comma 0. Vertical, 0 comma plus or minus a. So an oblique asymptote is going to be y is equal to plus or minus a over b, as opposed to b over a for horizontal. In vertical, we have y is equal to plus or minus a over b is equal to x for the asymptotes, as you see here. And in analysis for the equation of a vertical hyperbola, we have y squared in the beginning, as opposed to x squared in the beginning here for horizontal. And that'll wrap it up for hyperbolas. Oh, and hyperbolas only have 2 vertices, as opposed to 4 vertices for the ellipse. And that's all I have to say for this introductory video of hyperbolas. Bye-bye.